Today we will see examples related to grouped frequency distribution. Example: the height of children in a class was measured. The frequency distribution table shown below shows the data related to it. Convert the shown table into a continuous grouped frequency distribution table. The table shown below shows the discontinuous frequency distribution because the class intervals here are non-overlapping. That means there are gaps between upper and lower limits of two consecutive class intervals. Suppose the height of a child is 129.5 centimeter, then in which class interval will it be included in the table? Think. Let us tell. Since 129.5, this number is greater than 129, it cannot be included in the class interval 120 to 129. Similarly, 129.5, this number is smaller than 130, so it cannot be included in the class interval 130 to 139. Thus, this number cannot be included in any class interval. In such a situation, it is necessary for us to convert the discontinuous frequency distribution into a continuous frequency distribution table. So, let's start. To obtain a continuous frequency distribution, we must divide the class intervals. This will make the upper and lower limits of consecutive intervals equal. For this, we will subtract the upper limit of one class from the lower limit of the next class in consecutive order and divide the result by 2. Like we will subtract the upper class limit 129, which falls on 120 to 129 from the lower class limit 130 of the next class, 130 to 139, and divide the result by 2. This will give us the result as 0.5. Now we will subtract 0.5 from the lower limit of each class, such as 120 minus 0.5 is equal to 119.5. Similarly, we will add 0.5 to the upper limit of each class, like 129 plus 0.5 is equal to 129.5. In this way, we will create a new class interval 119.5 to 129.5. Now, you pause the video and similarly, in this way, find all the class intervals. You will get the class intervals as follows. Can you tell whether these class intervals are continuous or discontinuous? These are absolutely continuous class intervals. Now we can organize these groups in this way. Now, this table is a continuous frequency distribution table. Now can you tell in which class interval 129.5 will be included? Think. Absolutely right. 129.5 is overlapping between the class intervals 119.5 to 129.5 and 129.5 to 139.5. And we include overlapping observations in higher class intervals. So the number 129.5 will be included in the class intervals 129.5 to 139.5. Today, we saw an example of a grouped frequency distribution. In the next video, we will see some more examples related to this.